Hi everybody, welcome to the Duke Center for WaSH-AID. WaSH-AID stands for Water, Sanitation, Hygiene, and Infectious Disease. And we're a research lab studying all of those different things. We have a lot of focus on wastewater treatment and also on products for menstrual health and hygiene. And so we're going to get started with our laboratory tour in downtown Durham. Right now we're just outside the lab, and this is the area where you need to grab a lab coat and some safety glasses, and then we're gonna get going into the lab. So this is our general laboratory space where we have a lot of different bench tops where we can set up different experiments depending on the day. Right behind me we also have our safety shower, very important in case anybody spills anything on themselves during the tour today. This is where you want to come. We have our fire extinguisher in case there's a fire. Hopefully we won't have to deal with any of that today. If you look over here, we have a lot of other different safety supplies, so this is also just kind of a general storage area. But what we're going to do is we're going to walk through the rest of the lab space, and I'm going to point out different experiments that are currently in progress, or tell you a little bit about the different areas of the lab and what kind of work we do in those areas. So we're going to start our tour of the lab in the solids lab. So this is called the solids lab because this is the place where we do all of our experiments with solid material. And since we specialize in wastewater treatment, you might be able to guess what that is. This is the room where we handle all of our poop. So we have anonymous donors that donate poop, feces, also known as feces, and urine to the lab. And when we're ready to do experiments, we have to mix those together and generate our different wastewater samples. And so to do that, we have several different toilets in the lab. You can see one over here on my right. This is one of our experimental toilets. This project involves putting sensors into the pipes that are in the wall behind the toilet for early detection of diseases or to extract samples from behind the toilet so that the patient doesn't have to carry their poop sample to the doctor's office. You can imagine why that might be unpleasant, especially if you have a chronic disease where you have to deliver samples to your doctor on a really frequent basis, like weekly or even daily. Over here we have another toilet. This is installed over an anaerobic digester. That's this blue thing down here. It's similar to like a septic tank that would be buried in the ground. And what we're testing here is different technologies to separate everything that comes out of the toilet into primarily a liquid component or a solid component. So it might seem a little weird that we mix together urine and feces in the toilet and then try to separate it back out again. Why don't we just try to separate it before putting it in the toilet? The reason for that is that everybody uses a toilet, everybody knows how to use a toilet, and we don't want people to have to change their behavior when they're using the bathroom. All of our technologies really deal with stuff that comes after the toilet because people's hygiene habits are very ingrained from a very early age, and it's much harder to change people's behaviors than it is to change the technology that we're using. So as I mentioned, this is the room that sees a lot of action. We have a lot of different equipment that we keep in storage here. And then we also have, of course, a sink where we can clean everything up after we're done getting really messy in this part of the lab. So one of the things that we have to do is we have to collect all of our samples, our feces and our urine, and we do that through anonymous donations. We pay people basically for their poop and for their pee. If you want to become part of our donor program, you sign up and sign a consent form, and then you're given a barcode that's unique to you, and then you get these kits in which to donate your material. So this right here that I'm holding is what we call a poop hat, or a fecal sample collector, whichever you prefer. And this goes in your toilet bowl. You put it under this part under the seat so it holds it in place, and then you just do your business. So this is kind of the state of the art for if you go to the doctor and they need a poop sample, this is what you have to use. That's why it's kind of awkward to carry this around, and you have to maybe put it in your fridge before you go to the doctor's office. So this is a big part of what we're trying to improve upon with our technologies, to have sensing or other kinds of disease detection in the pipe behind the toilet. We also have bottles to collect urine, and when people do that, they bring it all back here, and then we keep it in the fridge until we need to use it for an experiment. So as you can see, if I open our fridge, we have lots of donation material ready to go. Whenever we need to start an experiment, we just take this into the room we were in before, in the solids lab, flush it in one of our toilets, and then we can take it out into the rest of the lab to do other experiments with it. All right, so now we've flushed some things in the toilet. We have our wastewater sample. Maybe we run it through another technology to try and do some process to clean up the wastewater. And now we're in our liquid sampling and testing area. This is the place where we run small scale bench experiments, and then we also test water quality to see how dirty the water coming in and out of our different experiments is. And to do that, we use something called UV vis spectroscopy that looks at changes in color to tell you what the changes in the chemistry of the water is. So I have an example here. Maybe you can see I have two different vials. One of them is more yellow and one of them is more green. And this is a test that tests for ammonia. So if you have ammonia in your sample, the color will be more green. And if you have no or little ammonia, the color will be yellow. We have lots of these different color tests. We test for, the common things we test for are ammonia, other forms of nitrogen, phosphorus, and phosphate specifically. And then we also test for something called COD, which stands for chemical oxygen demand. And that's basically a measure of how much organic material is in the water. All of these things are important to test for because if nitrogen, phosphorus, and COD are discharged from a wastewater treatment system, if they get out into the environment, they can cause all different kinds of environmental pollution. Nitrogen and phosphorus specifically can cause algae blooms, which can result in oxygen leaving the water. Basically, the algae grows a lot because the nitrogen and phosphorus are just fertilizers. So it grows, uses up all the oxygen in the water, and then the fish have no oxygen to breathe, and so they can die. Some algae also produce toxic chemicals that are harmful to humans. So often if there's a lake or a river or a seashore where there's an algae bloom, you'll see signs telling people not to swim there. And that's because the algae themselves can make toxic chemicals that can make the people sick or sometimes even result in death. So a big focus of what we do for water quality testing is making sure that these nutrients, nitrogen, phosphorus, and carbon, don't get out into the environment from the technologies that we're developing. Another thing that you can see right here is an experiment that's running right now to basically look at a material to absorb these pollutants from different wastewater samples. And this machine is one of my favorite machines. It's called the shaker. You can see why, because that's all it does all day is shake things. So next we're going to move over to the back of the lab, and we're going to take a closer look at what we call our fume hoods. So we've talked a lot about working with really dirty water and different kinds of wastewater. Sometimes we actually need to use really clean water for some of the work that we do. And so what you see over here up on this shelf, the blue filters up at the top and this little spout is what is our ultra high purity water system that we use in the lab. So this uses a bunch of different reverse osmosis and other kinds of membranes. It's kind of like a Brita filter on steroids. It can take not just organic molecules or heavy metals out of the water, but it basically takes everything out of the water. So what comes out of here is some of the purest water that exists on the planet. It's not good to drink because you need salts and electrolytes and other things like that in your body, but for doing really, really clean chemistry experiments, nothing gets better than this. So when we turn this on, we get really, really pure water up here. We also, of course, have the tap water, which we use for like flushing the toilet. This stuff is very expensive, so we only use it for experiments that we need to be really, really clean. In contrast to that, in this giant barrel here, we have, this is a 50-gallon barrel that we got delivered to us that is full of water from a septic tank. So a little bit later on, I'm going to show you an experiment where we're using water that comes out of a septic tank and trying to clean that up even more to help prevent environmental pollution. One thing I mentioned before is that sometimes we do small experiments and sometimes we do large experiments. So in this area of the lab right now, we have 2 different experiments set up, both of them looking at different wastewater treatment technologies. One of them right here is a little smaller, and this one over here to my right is much, much bigger. So let's start with the small one. This is an experiment. In this bucket, we've taken some of the septic tank water from that big tank over there. We have it here, and what we're doing is we're pumping it through a system that's using electricity to purify the water. And the way that works is that you have 2 different pieces of metal, you apply a voltage between them, and then things in the water that have a negative charge will try to go to the part of the metal that's positively charged, because opposite charges attract each other. In the same way, the electrode that's negatively charged, things in the water that are positively charged, like sodium or ammonium, will go to that electrode, and then we can separate them out of the water. So this is potentially a low-tech option where, as long as you have an electricity connection, you can hook this up on the end of your septic tank, and it'll prevent those nutrients I mentioned earlier, things like ammonium, phosphate, nitrate, from getting out into the environment and causing pollution problems. This system is designed to treat all of the water that comes out of a toilet for a household of 4 to 6 people per day. So this thing can treat 200 liters of water per day. And the way that it works is it has 3 different processes. It has this big thing right here, which is an ultrafiltration membrane. So this is just a fancy, really fine pore filter. And then that removes all of what we call the floaters. So the soluble poop particles that are, or not soluble, the insoluble particles that are floating around in the water. And then that goes into this column right here, which is a big column filled with activated carbon. It's exactly the same stuff that's in like a Brita filter. So this removes all of the soluble, the dissolved organic components from the water. And then that goes into this tank down here, which has an electrochemical system that uses electricity to turn the salts from your urine into the active ingredient in bleach. It oxidizes chloride ions into hypochlorous ions, and that disinfects the water and kills all the bacteria in it. And so we do a lot of testing with this system to make sure it's working, and we have one of these in India right now that we're doing field testing with, and we're currently talking to several different companies to see how we could license these and get these out into the world to start helping people who live in either rural areas or highly densely populated urban areas where there just isn't like a sewer infrastructure to do water treatment in the way that's common here where we live in Durham. So this blue device here is a prototype that we have for our menstrual hygiene product disposal system. And when I am menstruating, I take my pads or my tampons and I put them in the trash can, and somebody comes from the city and takes that to a solid waste landfill and it's gone. I don't have to worry about it anymore. But in a lot of places that's not an option, and women and girls don't have a safe way to dispose of their products, and so they end up missing school or missing work or having to stay home because it's kind of a taboo for them to be out in the world doing their normal day-to-day life. So this device is supposed to help give women and girls a safe, discreet way to dispose of their pads so that they don't have to worry about that anymore. And what this does is it has a slot in here where you can insert your menstrual hygiene product, and then inside there's a combustor, and that would be vented to outside the building. And what's unique about our product compared to other products like this that are on the market is that this produces very low emissions. So we're not polluting the air, we're reducing the menstrual waste to a very small amount of ash that comes out in this tray at the bottom. And then you could put this in a bathroom at like a school, or at a toilet block in a community, or at a train station, or other places like that. All right, so we're back out in the hallway now. One thing I didn't mention earlier is that, you know, we do spend a lot of time in the lab, but there's a lot of other work that we're involved in too. We do a lot of communication and outreach. We write a lot of papers. You can see on the window to my office here, these are all of the papers that have been written in our group. And, you know, we also have to have somewhere to eat and sit down. So we have all these offices. We have a little kitchen at the end of the hallway. And this is also a place we have a lot of whiteboards where we can sketch out ideas or brainstorm different new experiments that we want to run. I hope you had a really fun time coming on this tour with me. Don't forget to wash your hands before you leave. If you look below you in the cart, if you feel inclined to make a donation on your way out today, we would greatly appreciate it. My name is Lena again. Thanks for coming. If you have any questions, please feel free to reach out to me. Take care.